Hi everyone, this is Ram Vedam with Atlanta Functional Programming. Welcome to another episode of the Common Lisp Study Group. This week we don't have a particular topic scheduled, um, but I decided that we should do one of our Asks Us Anything sort of episodes where people who are watching, our viewers, can come ask us some questions in general about Common Lisp, either stuff that we covered in the past or just in general questions related to how to develop or even maintain or even explore the Common Lisp programming language and its ecosystem. I thought I would begin with a couple of things that I've been kind of exploring right now. Unfortunately, I didn't have enough time to actually complete my exploration, which is why I thought this would be a better format for today's episode. But the schedule is pretty free for all. So for folks who are just joining in today or right now, this is kind of what we're going to be going through. Before we get started in some common questions, as usual, Atlanta Functional Programming is looking for speakers. So for those of you who are in the Atlanta area and you guys are interested in giving a talk, even folks who are not in the Atlanta area and want to give a virtual talk, please let us know. I'm available as Bugram on the Functional Programming Slack channel as well as the Lisp Discord server. You can ping me there at any time and just provide your topic and when you want to give the talk, and we'll get you scheduled. Now that things are opening up again a little bit, we are planning on starting to have in-person discussions again. So those of you who are on the meetup, stay tuned, especially those who are in the Atlanta area, to come by. And of course, for our YouTube audience, we will have those talks recorded so that you can actually watch them live, as well as at your relaxed viewing, whenever you're available to actually watch them. Just a reminder for folks who are joining us tomorrow for the Haskell study group. We are continuing our discussion on functions and things that you could do with functions. This covers inside the Haskell programming book the what was it? It was chapter 7, I think it is. Yes, chapter 7. We are covering essentially, we've last time covered up to case expressions, which is section 7.5, which is similar to if else's, and we're going to be going on through higher order functions into guards and the point freestyle tomorrow, finishing off chapter 7 in the Haskell book that was written by Julie Morowski and Christopher Allen. Sorry, Julie Moronuki and Christopher Allen. Haskell programming from first principles. So that's tomorrow. For those of you who are going to be joining us, for folks who are joining us are covering either Learn You a Haskell or the other book, Real World Haskell. There is a couple things that I should warn you. The material that's in more functional patterns, and I encourage you to go to the Haskell book programming website to go and look at it for the table of contents, or even if you're, I do recommend actually purchasing the book for later reading. Just a reminder, that material is actually split across multiple sections inside Learn You a Haskell. So you're going to have to kind of like read bits and pieces from different chapters in order to get the same sort of material that we're covering tomorrow. So that's about it for announcements. Let's get straight into some code and talk about what I've been working on recently. So I get into these little stints every now and then on exploring different libraries in Common Lisp. And one library that has always been in my radar and a thing that I've been playing around with is Ken Tilton's cells. For folks who haven't heard about this library or who Kenny Tilton is a longtime Lisper. He's pretty active in Computable.Lisp back in the newsgroup days, although I'm not sure if it's still active right now. I'm pretty sure it is. He's also a fairly big Lisper that's been around inside the Lisp channel. If you guys squat on the Lisp channel in IRC, going into some pretty decent discussions. He most recently started moving over towards writing a lot of stuff in Clojure. He actually took this library that he wrote back in 2008. Actually, I think it was more like 2007. And he ported it over to ClojureScript. And this library, the cells library, is now called Matrix. That for folks who are looking in ClojureScript and JavaScript, it is there, and the engine and reactive engine follows the same principles that cells actually promoted. It's almost 11 years ago. A little longer than 11 years, because I think he moved it over to GitHub around 2010. Cells is a library that, and I'm not going to cover all of it, just what I've done so far. Cells actually is a library that uses a model that's very similar to what we now call data flow programming and reactive programming. He actually uses the analogy of, and this is how the library got named, of using spreadsheets. So folks who may have used spreadsheets, you may remember, I'm just going to use the VisiCalc style notation here, which is pretty useful to know. If you have, say, 1, 2, 3, these are your columns ABC, and inside ABC you have 1, 2, 3, and obviously we can also label this, like add this here and make this a 1, a 2, and this is your row number, obviously 3, 4, and 5, and then we can make this guy in spreadsheets equal to some calculation, say sum of A1 colon A2. Sum being a function that you would normally use inside your spreadsheet. And obviously here you'd want hold on one second. Let's move this over here. And obviously here, what would happen is when you select enter on this equation, we all know what happens. This will, obviously get removed, get calculated by the spreadsheet engine. You'll get 4, and if you change any of your cells in your spreadsheet, like if you change this to 4, this will, update automatically. Okay, so that's the idea of the model that cells is kind of inspired after. Okay, it's this very quick data change update to make sure that your model is all consistent. This this is obviously not new for folks who are familiar with reactive programming, or if you're coming from the RX world, okay, in the reactive world. It was also available if you used the observable syntax inside uh, .NET early on. In fact, the author of the RX libraries, Eric Meyer, he encountered a lot of this way back around the same time that Cells was invented and was created for Common Lisp. And he encountered something similar, and he adopted that as interfaces inside of the C# programming language. Later on, he ended up creating some more implicit observables that are very similar to how Cells was created, and used that to create RX, first RX.NET, and then RxJava subsequently. And we know ReactiveX.io, which gives you all of the RX frameworks now for pretty much any language you could think of, is available in that realm. So Cells is available inside Quick Lisp, and what I've been trying to do is kind of recreate some of the simpler examples that I've seen, because there was a talk that he gave back in 2003 when he first released Cells for Common Lisp back at ILC, and I was trying to find that talk just because it had a fairly decent examples on how to leverage the Cells library with some simple examples and growing up on things like this. One thing for folks who are interested in looking at Cells in general to note is Cells has an updated talk that is available in its entirety from 2018. I think this was his talk that he gave at Lisp NYC, Lispnik. But that one, if I still have it open somewhere, if I recall, a lot of the examples in this library, in this kind of presentation, was focusing on not only Common Lisp in some of his earlier examples, but he updated it to actually show his examples using Clojure instead. So folks who are looking at this, who are Clojure programmers as well, and you want to take a look at Cells, which is available in Clojure, you could certainly do so and get examples from this 2018 presentation. Obviously, I won't. All Lisps are welcomed around here, although we're going to be focusing on Common Lisp here. I just thought for folks who may be interested in this library in general, during my exploration, I encountered that bit of information that I'm just sharing with you today. So you could certainly use it if you are coming in from that route. And again, folks, this is a free-for-all, so, ask questions on the stream, and when I, encounter any questions, I will stop myself and answer them accordingly. So the one thing that I think I found. The one thing that was mentioned in here is that was mentioned in the Cells documentation, and I'm looking at the quick reference guide and the README mainly. is that there really isn't much documentation on how cells works, other than the test suite that's available. So I started looking into that, and I can show you so far what I've kind of deciphered from the test suite. And the main reason is if you read the motivation and documentation about cells in general, it gives you some basic example, some basic idea of what a cell is and the different types of cells, and the basic idea of data flow. But there isn't any examples that from usage in the cells library outside the test suite. So that's kind of where I started with. But the actual motivation page, which is available on the wiki inside GitHub, is actually really, really good in explaining what is the motivation and how def model works and so forth. For folks who don't know what def model is basically Cells' way of creating your property model. It essentially encounters a simple, spreadsheet type of like structure. It's a data structure that holds all the cells and allows them to be computable or not. And there's different properties that you can attach to a cell. And obviously, since this was written in class, you have the ability to have subclasses and an inheritance hierarchy related to it. Okay, so the GitHub link to cells is actually, there's a question on this, is located in, if I remember correctly, it was this one, right? Cells, yes. So, let me just post this guy for folks who are interested. Here it is for cells library URL is this guy, and let me feel free to change this here as well. So I will also put along with it being in the chat links for folks who are watching the live stream right now. I will also post it in the YouTube description, just because I am mentioning it as a library in today's discussion. Again, though, this is not me presenting on cells. I'm going to do a more formal presentation on it. This is just me kind of like giving you kind of like a report as to what I've explored thus far. I need to obviously go through the test suite a little bit more to encounter some of this, because if we go to the test suite, now I have to go and remember this here. If I do that, and go into as well this, I think, no. Lisp, quick Lisp, this, quick Lisp, software, cells, test.lisp, probably the best one. This is a simple example. It's probably the example that I want to go through. Local variable list contains values that may not be safe. Yes, go ahead. Okay. It'd be better if I do this. This. There we go. Okay. So one thing to note about cells, for folks just interested in understanding the concept, um, cells uses a property model. And again, I'm kind of working through my memory on this because I looked at this at one point, but did not dig into it too deeply. But the idea is very, very simple. Um, you have a model, let's say an object of properties. Okay, some of these properties are fixed properties. Think of them like values inside of a spreadsheet. Those cells are cells that can be changed, but they ultimately do not get updated automatically by this higher level property model upon which you build some stuff. Much like in a spreadsheet, you have cells that you could change, all right, but they themselves don't compute anything. Okay. On top of this, you have also computable cells. All right, these are cells that are associated with some sort of rule, and that the name again is called a ruled cell. Um, and the ones that I'm talking about, where user input is probably what's going to be most likely going to be dealing with the cell state and changing the cell state, those are called input cells. Okay. And what happens is the ruled cells will have some sort of formula associated with them. Okay. And the input cells is the ones that are getting values at runtime, probably through either some external data source or maybe even, in this case, user input, which if you think about it from an abstraction point of view, is still kind of the same idea as getting it from an external data source. They're just streams of unpredictable inputs coming in, right, at any given point in time, right? And what happens is anytime a ruled cell's input cells get changed. And what I mean by that is it is anytime the input cells that we provide in the model get updated, any rule that uses those input cells will get updated automatically. There's this implicit observer model. If you think about the observer pattern, this is essentially what the observer pattern does. It sees a change to some observable value, and it automatically triggers whatever callbacks that you have registered whenever this value gets changed. All right, it's the same idea. Um, and of course, there's other types of cells too as well. And one of them is called lazy ruled cells, which is a computable property isn't computed until it is requested. This follows kind of imposing some level of lazy evaluation on top of the model, so you don't have potentially expensive calculations occurring when ultimately that expensive calculation, the result of it, will never be used. And again, we'll be covering some of this a little bit more in a separate talk, but this is particularly useful to know conceptually when you are encountering it. The one example that was in here, I'm hoping I could find a model. That I can actually leverage. Let's see. This is a test suite. Let me go up to observer. So that's the observer class that they're registering. Okay. Okay. I think I could use this one as a basic idea. So just to illustrate just a basic idea of this, let's say that we have a hello cells kind of model, all right, that has no subclasses. And this model here essentially is a macro that converts into a def class behind the scenes for folks who are looking at this. You can actually go in, and again, I'm not going to dig into too much detail about this beyond just showing you this quick illustration example. You could, have some input cells. Let's call this X init form. Let's say that this is going to be a cell Cin, and the initial value is just going to be 0. Right? The accessor is going to be let's say input A, okay, just to make things a little bit more cleaner. You'll see this, and let's even add this as an init arg so we can construct it with some predefined value too as well. Input A, okay, and let's go ahead and put another one sort of the same way. Just to, again, show you what this does. Init arg input B accessor input B. Okay, so these are two cells. If you think of this from the standpoint of a spreadsheet, these are essentially associated with these top rows here. Just cell A1 and maybe like B2 or something like that. Or in our example, it's going to be A1 and A2, right? And then let's say that we have an output, okay? And we'll call it output. And this one has only a reader, okay? We won't allow it to be changed from the outside. And what we could do here is we can actually add a rule, as you can see by this init form here. And the way that rule is written is you have something called a condition here. And you have C question mark. And there's many different types of these question marks which I haven't covered and haven't actually really explored yet, which is why I'm just showing you the example that I've touched so far. I will answer this one question right after I just showed this one brief example. So here we can actually say can actually calculate the let's say adding of these two these cells. So we can just say this is a sum block or something like that. Okay. And what we do is we basically do, if I remember correctly, we do cells thought we can just do cells input A and input B. Let me go into one thing here, which is here. Try this one. Yeah, I have to use that. Okay. Let's see if I could do input A and cells input B. Okay, so we can now Let's check this one thing. Oh, this is in, if I use def mod, not def model. Yeah. Okay, so he made even a simpler one, then I can do this. So this is something that, like I said, I am going to have to learn a little bit more. This is the old way of doing this. You'd want to use this. You don't even have to add all this stuff because the cells can actually grab it for you. I did not realize that this was there. Cells, cin. Let's see this. Cells c question mark plus cells input a cells input b. Right. Okay. So see this. Do I need it? Maybe I don't need this here because this is not odd number of key arguments. Yeah, there's an encounter there that I have to go through. Like I said, this is probably the best one that I've seen. But for some reason, like I said, this is still what I've been encountering in right now. With some of the examples, they don't have they have all these predefined things that we're trying to leverage, but really, I don't think you need to do these. I think what we could do is just simply say input A and input B, and it should actually go ahead and label that. But there it is. All right. Like I said, there's still some stuff that I have to learn about this library. But I was hoping that I can come up with the example that I was showing you before. I was hoping that was going to be pretty simple, but it looks like I still have to do some digging into here. So let's get to questions. There was a question regarding, I find some Lisp libraries lack documentation. As a newbie, I often find it difficult to read the source code to learn its usage. What would be your recommendation? So as you're learning to as you're learning Common Lisp, oftentimes you're going to end up realizing that at least with respect to libraries that lack documentation, it is often the case that their basic usage is in their unit tests rather than their actual source code. What I found very useful now, going at this in various shapes and forms over the years, is looking at their unit tests for basic usage and then constructing your own basic documentation for the exported symbols is one way of encountering and one way of actually mitigating and being able to use those libraries directly. At the same time, I do feel that this is a little bit of a sticking point with a lot of libraries. It's something that I encountered myself, something that we've encountered on the stream on several occasions, where we had to go and look at what it might have said in some sort of blog post or documentation that was either what I'd like to call dead upon arrival. As soon as they published it, they decided that they needed to change something in the API, which means the quote-unquote blog post no longer is valid. In those situations, I think asking questions on the Lisp Discord server or even on the Lisp channel on, I guess, what is now called LiberaChat is probably a good place to go to for information regarding it. And so my recommendation really is to start looking at the test suites and to look for basic usage, and that should help you go along, go very far. Outside of that, obviously go to chat rooms on both Discord and IRC for additional information. Once you started getting a sense on how a particular library works, I strongly encourage those of you who are really getting into and understanding those libraries to write documentation. I know this is something that we often forget and we often feel like is the last thing we should do, but it really does help some of the project maintainers and stuff if users, especially those who are going through and picking up libraries, to write documentation. And it could be as simple as just writing a simple website that's posted on, say, GitHub pages. Obviously, curating and getting that in a centralized location would be useful. That's a longer term goal. The documentation has to exist, right? And some of these libraries were written, and they're really well done if you actually look at their test suites. It's just conceptually it might take a little bit of getting used to in order to disseminate that information to other users to realize the usefulness and usability and real intuitiveness of a particular library. And again, this goes back to really folks understanding what is considered to be a macro versus something that is really just a function call. Just even having that documented in a clear way and knowing how to leverage the macro is will take us very far. I've encountered that in a couple of places and trying to figure out ways of embracing that. But I have yet to actually sit down and write some of that. In fact, I was thinking about figuring out ways of actually documenting my sales experience so that other folks may not encounter the same kind of roadblocks I have as I sit down and start looking at some of this stuff. Okay, next question. Which unit test library do you use? Me personally, because I use Roswell a lot, and I try to integrate myself with whatever is in Roswell to make it easier to use the project structure. Honestly, I do use a lot of Fukamachi's skeletal frameworks, and this includes CL project for me generating project templates that will quickly be able to be prepared for distribution on, say, Quick Lisp. My unit test of choice is Prove, just merely because, again, the project template that Fukamachi creates integrates proof very well into its templates, and it has what I need. At one point in time, I was using Lisp Unit. Lisp Unit is still very well well done. Honestly, I only switched away from it just because it was I wasn't entirely sure how to set up the project structure for its use. It's something similar to what 5am does, which I also looked at, but 5am has a lot of stuff that for my use cases, for my uses, really, there's just a lot of stuff in there that I probably wouldn't use, or I haven't had a use case to use yet. All those are very good frameworks, fairly well documented. 5am actually is a lot more is pretty decently documented, honestly. I encourage you to take a look at 5am. If I was doing new projects again and again, if I was using something other than CL project to set up my project structure, I would probably use that. How do you run the test? Do you have a key binding? That's actually a very good question. I personally just load the test package into my image and just do run tests automatically in the REPL. Sometimes I have a scratch buffer open that just has the run test function, so I could just use Control C, which is the slide bindings to evaluate something in the REPL to get it running. But yeah, so you can certainly actually write a quick script to load the image and run your tests too as well. That can get triggered. One thing that I've been thinking about in my head, but I'm not entirely sure how to quite execute it, to be quite honest, is how might I, for example, if I change a function that has a test already associated with it, how can I set that up so that it can automatically run, so I can get those test suites running too as well. Projectile has the projectile test project command, but I've not. So oftentimes, and I'm not sure if this is true for all projects, because older projects have a different project structure. Okay, and this is kind of something that I'm trying to allude to, but I'm going to say explicitly right now. Each project will have its test structure created slightly differently. All right. Some may have an actual system definition in the ASD file that you could just simply load by doing like a quick load into your image, and then that function gets registered. Others may have it has a package, and you're going to have to go in and figure out what package has already been loaded into the Lisp image in order for you to run it. In this case, it sounds like, and I would have to go and look that up because I honestly don't know. I haven't heard of projectile, the projectile project. But my guess is it is an exported symbol in a package, in which case you could just simply call that like any other function. So it'll be find the package name, colon, that function command, and then you should be able to run that automatically. If you really want to, you could simply write a key binding that registers that function for the lifetime of a session. There's ways of doing that in Emacs, but I'll be honest with you, I'm not an Emacs Lisp expert. I kind of picked up a couple things over the years. So for folks who are Emacs Lisp experts, feel free to provide suggestions on how to do that. I just have some personal conveniences that I use to encounter that. At the suggestion of one of our viewers, I will post for folks who are interested regarding the unit test library answer all on. Let me put a couple of these links for you. There was Lisp unit is what I used. It was this one. Now this is the older clicky link, but there are some newer ones too as well. There's also 5 a.m. Common Lisp, which has some really good documentation. I think this is the one. Yeah, this is the one. One of the things that, and I may at one point actually do a talk dedicated to this. One of the features that's in 5 a.m. that I recently started looking at from a general testing point of view is for folks coming from the Haskell world or who are aware of specification testing, like quick check from the Haskell world. You may have encountered this, probably like saying either using hypothesis in Python or Hedgehog or what have you. 5 a.m. actually provides a way of writing specification-based tests for you to randomize your testing and get some nice tests. It's really, 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 really nice. So check that one out. There was actually, I'm trying to find it. There was recently a blog post that was posted on, I think, Lisp.reddit that covers quite a few unit testing frameworks in Common Lisp that might be useful for folks. I think it was in Read the Docs or something like that. Let me just go back to this. I think it was if you use the Common Lisp, yeah, that's the other one that I forgot to mention. Let me just go grab that one too, which is the Prove Common Lisp framework. This one is also pretty useful. One of the nice things about Prove, for folks who are just tuning in, okay, so, okay, nice. A couple of questions about, okay, so let me answer the second question there. So let me answer the second question regarding scientific computing. Common Lisp has a very strong history with scientific computing. I don't think I can really provide good examples that will illustrate its power. I think honestly, if you just simply Google Lisp and scientific scientific computing in Common Lisp, you'll encounter several of the examples that really illustrate its power. Because a lot of folks use Common Lisp in a lot of stuff. One immediate thing that comes into mind that you can definitely look at is the recent success of Clasp for Common Lisp as well. Clasp actually is used for molecular computing, and honestly, Dr. Schaffenmeister, who for most people who are is known as DR Meister in the Lisp world, he really has provided more than enough material. There's several talks by him talking about the power of using Common Lisp for his use cases. And I think you could certainly extrapolate from that on its potential on using it in other cases as well. But me personally, I can't really talk to that just because I haven't actually used it in scientific computing. So I don't have an opinion on that. But I have seen others use it to various levels of success. Regarding the comment on Awesome Lisp, yes, for folks, I've actually mentioned this particular curated list, this Awesome CL list, several times on the stream, but I will post this also in the chat. This list has a lot more other frameworks listed for things, and these are, I think, a lot of them are documented actually in terms of their API documentation. And you can check these. There are quite a few testing frameworks in that too as well that you could check out. In there, also, if I remember correctly, in the tools section, you will also see a link to Fukamachi's Modern Project Skeleton CL project, which is the one that I use for my purposes. Here we go. Finally, for a good comparison of testing, there is also this effort too that I think I want to highlight as well, that folks might be interested in, and that is the Common Lisp library read the docs effort. This has several libraries documented in there with various examples, some of which have various levels of maturity.
Still there?
Yes. Mm-hmm. Another question here. What are the advantages of using an IDE like LispWorks compared to SBCL? Is it worthwhile to get a commercial Lisp? Honestly, I can't really answer that question because I've used Allegro CL's Express Edition and LispWorks Express Edition, and from my point of view, there are some advantages, especially if you're writing executables, if you're doing SMP, symmetric multiprocessing. They have a lot of advantages with very mature frameworks and ecosystems for doing GUI programming that honestly the open source community has been trying to unify on through the efforts in CLIM, but I think they're still a few years behind what the commercial efforts has. Additionally, if you're doing some stuff with mobile applications, especially, this is something that is somewhat limiting right now in the open source world. There isn't a Lisp distro, as far as I know, that can create like a package, an open source Lisp implementation that could create like a package that you could run in addition to whatever inside your iOS or Android applications, whereas there is the commercial Lisp Mocal, MOCL, that will give you that ability. I encourage you to go and take a look at that. That's actually a really good one that will allow you to write a lot of your business logic in Common Lisp, and you could then leverage the GUI choice of, the GUI framework of your choice. In the case of iOS, you could even write the UI in Swift and then write the business logic in Common Lisp, and you can get pretty far ahead there. But those are focusing mainly on the mobile side. In terms of like desktops and services side, there are advantages of using a commercial Lisp. For example, if you're using graph databases and you're using Allegro Graph, leaning towards using Allegro CL will give you more advantages than, say, using another Lisp with Allegro Graph, just mainly because of the fact that although there are connections to Allegro Graph where you could write your stuff in an open source Lisp and hooks into it, most of those APIs end up behind the scenes, I think, making a network call that if you're using just Lisp directly using Allegro CL, they have some optimizations that happen behind the scenes there. What is my opinion of closure-like threading macros? So I'm assuming you mean thread first and thread last. So I actually do enjoy using thread first and thread last in Clojure. And I will say that thanks to the efforts, I think in either Alexandria or Serapium, one of the two, you do have those macros available to you inside Common Lisp as well, but their libraries are not part of the core implementation. So there is Clojure to language and Clojure to library, and just like that, we have Common Lisp to language and Common Lisp to standard library. There's a bunch of core stuff that's in Common Lisp that you could say Common Lisp core. That includes things like conditions, CLOS, a lot of special forms, as well as whatever's documented in CLHS. But I will say in the hyperspec, it also has some stuff that I would consider to be part of the standard quote-unquote library that should be available in every Lisp implementation. That is something that I could say that if you, especially newcomers to Common Lisp, as you are writing more and more code in Common Lisp, you'll understand, oh, this is part of the standard library versus this is being something part of the core language. That will just come to you just through usage. Can folks hear me right now on the stream? Stream. Okay. All right. So there was a question earlier on technical difficulties. All right. Okay, let's continue. So there was a question about what motivates me to do these streams. I think that's a very good question. I've been doing this for almost now, I think I realized 3 years just the other day. I think it's always good to remind oneself to talk about one's motivations just to make sure things are always in check, right? Like many newcomers to Common Lisp, I was like that, the same person like you guys when I encountered Common Lisp on and off for the past 10 years. There wasn't any real like effort from my standpoint, from the standpoint of the community in some cases. Like there were a lot of active efforts for documenting the libraries and stuff, but really there wasn't kind of a forum where we can just really discuss Common Lisp. And I wanted to discuss Common Lisp and really study it. not only do you have really good books like Practical Common Lisp out there, but Sonia Keene's book on object-oriented programming, which teaches you something very different about writing an object-oriented program than what, say, what we learn in school. Specifically, when you start encountering taking advantage of the dynamicity of being in an image-based environment to update your implementations, all right, and change their actual structures while the system is running is, eye-opening. It's really, really useful. I want to really kind of embrace and kind of promote, there is a way of writing that, doing that kind of interactive programming, while at the same time set it up so that people can actually do practical work done. And I think having a stream like this be like supplementary material to some of the books out there really helps kind of drive home, some of the usefulness that Common Lisp has. And honestly, compared to most of the programming languages that are currently in active use right now, all right, and I've used, and I'm talking about dynamic programming languages right now just for the sake of the illustrating this particular point. I've tried Python, I've tried Ruby, I've tried Perl, I've tried, and I've been writing them in various iterations, and I started learning Clojure. Common Lisp has a lot more going for it than most people realize, and it's still a contender for even writing pretty high-performant web services and really high-performant applications today. And that should stand as a testament to its design. And yes, although there was cruft, because at the time that Common Lisp was created, there was over 30 different Lisps, in active use in various shapes or forms. Some of the major implementations, had extensions for object orientation that are still in existing systems that are probably in use today. Being able to unify that and be able to come up with a set of standards that everybody can else use, I have to give them credit. I mean, this is something that cannot be understated. Yes, I wish the situation was a little bit better in terms of making things easier and easier over time. But the fact that you can actually take a piece of code that was written in, say, 1960, and there is an AI program out there that will do it, and run it on an image in 2021, and it compiles, which can often be the case that it cannot compile if you're using another language, like say C. I mean, you're using a language that you're really using building material. Okay, there's a question about slime versus sly. Honestly, if you're a newcomer, it makes no difference. They have the same key bindings. They have the same ability to run multiple Lisps. Sly has some really awesome functionality related to tracing and being able to debug, mainly the stickers feature. I haven't encountered a situation in our streams where I needed to really illustrate and show this particular feature, but if you look at the documentation, it really does. I really suggest most people, if you're just starting out, use whatever makes it easier for you to hit the ground running. All right. Slime is very easy to build. If you're using Quick Lisp, it could set up Slime for you easily by just running Quick Lisp Slime helper. I heard somewhere that there is a similar function that was added to Quick Lisp for Sly for Sylvester, but I've never actually used it. Okay, so there's a comment regarding the establishment of Common Lisp with DARPA herding the goats, particularly along Route 128 in Cambridge. I'm assuming you're talking about all the different Lisp implementations, but yes, that is a good analogy. I think that's something that cannot be understated. It is when you have that diverse of a Lisp ecosystem, you want efforts to be focusing on one or two, particular pieces of information. Okay. Let's see here. Question. Wait, George, why? Why what? We have a viewer that says why, but I'm not entirely sure what the why is related to, so I'm going to let you finish your question. Would I recommend to start a commercial project with Common Lisp? Is it difficult to get developers? I personally would recommend people to start commercial projects with Common Lisp. This is slight bias, but there is something to be said about again, just the power of Common Lisp and its ability to write projects and write established software that cannot be understated. More importantly, and I think this is more to the point, I feel there are industrial level libraries already available to do the majority of things that most people are doing in other languages. Okay, nowadays, especially the space in web services. I cannot stress this enough. There are fairly decent, fairly mature web services frameworks, pending from your Rails-like frameworks in Caveman to something that's even Sinatra-based like Ningle, to something that just does REST like CL REST AS. Okay, REST has. There's also other ones that could that implement in the commercial Lisps those kinds of abilities. And if you're trying to essentially create something that will ultimately run in a Docker container that's in a service environment, your choices are very, very, I mean, it can be any of them. And I don't see any reason why Common Lisp should be considered something like a dead language or even something that isn't viable for commercial use. I can argue, some things related to potentially misuse of the features of Common Lisp. For example, macros always screw people up because they don't know entirely when a macro is useful, where a higher order function would be probably better. But this is the same mistake you could see in any other language. Okay, a lot of folks like reinventing standard algorithms that are probably already available in their standard library. All right. And even in the Python world, the Python object model is hardly ever properly used. If you wrote a proper library in Python, for example, you'd want to leverage that object model because then you get access to the standard algorithms for free because they all behind the scenes call those, those dunder methods, those double underscore methods that are so popular in that language. In much of the same light there, Common Lisp has a bunch of libraries and a bunch of functions available at your disposal, and I don't see it not being any more than an evaluation than using Python. In terms of finding programmers, there are a lot more Common Lisp programmers than is known. I feel like a lot of times it's because they kind of since Common Lisp isn't very popular, it's not one of the things that people talk about. So there's a question: what are some decent alternatives to Numpy and Matplotlib for people that get tired of Python? So I've heard efforts in this realm in the efforts of NumCL for numeric computing, and that's written by the guys over at IBM. I'm forgetting their names right now. If you look at the Common Lisp Read the Docs page, it actually has it listed in there. with some basics examples. I don't know how mature it is compared to, say, Numpy, because you got to remember NumPy has been around for NumPy has been around for quite a while right now. So I recommend you taking a look at that. In terms of Matplotlib and stuff, I mean, in terms of symbolic computation in general, the only thing I could think of for you to take a look at to see the strength of Common Lisp in that realm, other than talking to, obviously, Dr. Meister on Clasp, is Maxima. Just Google Maxima Common Lisp, and it will. I think that project will convince you about Common Lisp strength for doing numerical and symbolic computation. And there was another one related to Maxima, actually, again, written by the guys at IBM. I don't remember what that effort is, and there was a documentation effort to actually get that done too, but I don't recall how far that is and how mature that is. Okay, so there was a question that I just overlooked here that caught my eye that I'm going to talk about. That is why many books do not cover Common Lisp object system when teaching Common Lisp. Now, one of the viewers pointed out, Practical Common Lisp does, and Sonia Keen's book really is awesome in terms of actually covering a lot of the core stuff for object-oriented programming in Common Lisp. In addition to that, though, I would really say Reflection and the Art of the Meta-Object Protocol is another great book that covers essentially Common Lisp object system, but it covers it from the standpoint of us talking about how do we write an object system if we have the Common Lisp object system. How do we set that up? How do we set up all the infrastructure to kind of, how do we build the Common Lisp object system or object-oriented programming like an object-oriented program? That's essentially what the meta-object protocol talks about, and we kind of actually discussed this when we covered the meta-object protocol on this stream. But that's another place where you will encounter the usefulness of the Common Lisp object system and the versatility of it. Because if you look at other object systems, they all have that singular object model that they learned from, say, Simulink and from Smalltalk, but they didn't really embrace what Smalltalk was talking about in terms of message passing. But to quote Alan Kay, Common Lisp and Smalltalk, he considers both as being purely object-oriented, with regards to the definition he was talking about. He cannot think of another example that embraces that. Other questions? Ask away. Please type them in the chat, and I will take a look at them. This is an interesting question. Have there been any attempts at adding a type system to Common Lisp? So there's a misconception here, thinking that Common Lisp doesn't have a type system. Common Lisp does have a type system. That's the stuff that we talked about when we were talking about def the satisfies, and so that's the first misconception that I want to kind of clarify. There is a type system already available. I think the question that you're really trying to ask is, have there been any attempts at adding making Common Lisp statically typed, okay, instead of dynamically typed? This is a question that Okay, so there is a hold on, I'm getting a little bit of a technical difficulty here. Let me see. Here. Let's do this. Shut down this guy. And let's shut down this. Okay. All right. And let's capture it. All right. So there's this question regarding, so let me continue on here. We're having some technical I'm having some technical difficulties. I'm hoping that the stream is not shoddy because I'm getting some warnings here from YouTube. So forgive me for folks who are on the stream right now. So to answer that question regarding static typing, honestly, it's a question that I've thought about, and I think looking back at it, there are certain things that cannot be done in Common Lisp if you start adding static typing. So let me try and explain my understanding of this from the perspective here, in terms of what we've been covering in our Haskell group, and give an analogy from that point of view. When you're coming from the Haskell school in terms of static typing, okay, and you start embracing parametric polymorphism through type classes, right? Generic functions, as they are being defined in that world, require a multi-pass parse to occur, mainly to verify type checking at every stage during the parse to make sure that everything is properly typed and has the correct type and we don't actually violate any type constraints, all right? So your parsing level actually becomes, as I understand it, much more complicated, all right? In Common Lisp, because of macros are essentially code expansion, okay? But they're not dealing with the parse. They're not actually dealing with parsing necessarily and type checking at that level of during expansion time, okay? So in order for static typing to really work is you need to push that type checking, which normally occurs during eval, if I'm not mistaken, has to occur during eval really to verify all the types that occurred. You have to move it up into the reader phase, which will complicate things and will change actually the semantics at which you are actually doing the macro expansion. All right. This is similar to what templates does, as I understand it in C++. They have to do a parse, validate the check the types, then expand to a new to the C++ code because you're using C++ templates to instantiate either a function template or a class template. And then you have to run the parse again to make sure you have valid C++ again. Otherwise, you'll get a compiler error. So you have to move all that checking, which is normally done in eval, up. And that's changing the semantics in the language. So I don't know if you can necessarily do that. I say that the benefit of what Common Lisp does is if you wanted to add a pseudo type checking phase in the read, thanks to reader macros, you could certainly do so. All right. So while static typing itself may not be able to be added and make a statically typed Common Lisp. And again, if there are Lisp experts out there that are watching the stream or watch the stream at some point in time saying he's full of crap, just feel free to come and tell me you're not understanding what's happening and clarifying it, and by all means explain it. But this is how I understand it, and this is kind of what I'm kind of concluding to based on my experiences. All right. So there's a question about my opinion on Guile and Gwix. I will. I'll handle that question in just a minute. So there's a comment here regarding my question about static typing. Actually, SBCL does some static type checking. I'm not entirely sure. I heard that this occurs in SBCL. I just don't know where that happens, and I can't say for certain that that's what happens. So if you know exactly how it does static type checking, please let me know. I know with type annotations, I think it does do some sort of like checking during the parse phase, but I'm not during read. But I really thought that that still is passed through to the evaluator, and during eval, those types are then satisfied. Because otherwise, there's some complex constraints like the satisfies constraints, and I don't know unless you eval it, would be able to actually go and do the type checking there. So I'm thinking about the satisfies clause and form when you do a def type in certain types of complex conditions. Okay, so there's a comment related to that, and it says that the compiler does it. Okay. Okay. I think that makes sense, but so the compiler, the response is it sees the type declarations, it also does type inference at that point as well. Okay, so that's how type inference is implemented. Okay, that makes sense. All right. But the compiler would have to wait until read is completely done in order for you to actually start running through in those type declarations and then do some type inferences, right? Okay, right. So there's the comment here is that CMU CL invented that type inferencing and with the type declarations. Yeah, I recall reading somewhere that is true. But my question is because in some cases when you start talking about statically compiled Lisp, right, statically typed Lisp, you're declaring it ahead of time, and for certain types of type checking, if you want the kind of stringent type checking you're normally seeing in, say, C++, that can't necessarily occur. It has to relax it because sometimes the inferencer might infer a type that doesn't actually match what the type is declaring, and at that point it will relax it or warn you that this is what's happening, and it will still compile the code. Right? It's not actually a type error at that point. It's kind of what I was kind of getting at. When most people are thinking of statically typing, they're thinking of type errors coming from other languages like C++ or even Java, where if you have a type and it says that it is of this type and you pass in an invalid type, all right, and they're disjoint, it won't necessarily throw up an error at runtime. It'll actually not compile the class file. I hope that makes sense. So there were some comments about the compiler warning you, and you'll see the reason why. Yeah, I know. I've seen that, and it does warn you, but it will still successfully. It doesn't abort compilation. Is my I think what a lot of folks are asking for when they're talking about. I understand that, and I've actually seen that happen. I've actually corrected that. I just don't think you can get the kind of static typing that where it aborts compilation when it sees such a type error. It will just relax the constraints. But you're right. I'm not. That's a very interesting comment here. There's a comment here that the Lisp bar is bringing up related to the fact that the type language of Common Lisp is not that expressive. Honestly, I can't really make a judgment on that because I don't know of an example of a really quote-unquote expressive type language. Maybe type classes, but I don't even know if that we would consider type classes and the kind of features that are available in Haskell, even in that realm as well. So that's an interesting question. You can turn warnings into errors. In SBCL, there's a command to actually treat warnings as errors. That I did not realize, but that's good to know. That's that's something that I did not realize existed in SBCL. But that's great. That I should have expected that, but you know, it's SBCL warnings and errors. That's actually interesting. I'm gonna make a note of this so folks, I can show folks later on. Here we go. So for folks who are using SBCL, section 415, I think it was, type errors, no, 441, compiler errors, will teach you how to turn on compiler errors and make them into compiler errors in SBCL. But there are some ways of getting it. So, but the type system itself does exist in Common Lisp and has Lisp bar has been pointing out there is some sort of static type checking that occurs during compile time. There are mostly when a type error, according to section 441, it does warn you that of that type error when it's trying to compile the code because it's of the consistency constraint, but you can make it even more stringent, apparently. I've never encountered that, so I can't really talk through that particular piece, to be quite honest. All right. So there was a question related to just reading code, especially when it comes to Common Lisp. And the comment goes, our poster realized to get better at Common Lisp, you have to read a lot of code, but it's not always easy to do it efficiently without getting too far into the weeds. My response to this is, when you're reading Common Lisp, just like when you're reading any other code, the debugger is your friend. When you're exploring, you can certainly read through a certain point in your journey, and a lot of it, if you figure out the right entrance function, going through and figuring out how things work will become pretty straightforward. A lot of times, just isolating yourself to a particular function and how that function works will do you a lot of good. A lot of Common Lisp practices are functional in nature because Common Lisp kind of embraced the functional style of programming. So if you kind of understand higher order functions and how function arguments are passed in as first-class citizens, some of the basic uses of Common Lisp becomes fairly straightforward. It's just he's applying this higher order function with this custom function that he's passing in. It has a predicate in the case of sort and filter and all that kind of stuff to apply against some data structure. Now, when it comes to libraries that implement their own paradigm, and we've covered one of them here recently, a couple of actually. Fset is an example that has a purely functional base of how to embrace functional programming, Common Lisp, that in some cases interacts very well with Common Lisp's way of doing functional style programming, but in other cases does not. And we've even covered interface passing style in the with the Lisp interface library, which is a completely different way of embracing dispatch inside Common Lisp. In those cases, it's often best to start with, like I said, with learning any other API, the tests that they write in their unit test suites to actually figure out their use. Now, if you find a particular Lisp library or API that doesn't even have tests, at that point, I'll be a little bit scared. I'll be honest with you. That requires a little bit more trial and error. It might often be the case that you will end up probably writing tests that will similarly illustrate some of the functionality there. At that point, I would suggest to submit a pull request for some of those things, saying, "Hey, I tried to figure out how your use case, your library works. I wrote these tests, and I realized that there are these uses. Could you, clarify them or do whatever?" That would help also as well to actually get better at reading and writing Common Lisp code as a whole. This is pretty standard regardless of what programming language you come from. If you're going to be learning a library, the library and I'm going to not even say library alone. I'm going to say library, framework, or whatever, all right? They come with a particular paradigm that they had in mind. And you need to first understand that paradigm and how to use it within the respect of that paradigm before trying to essentially become creative and use that library outside of that paradigm. Because what ends up happening is a lot of folks don't necessarily learn the library and don't learn what it was originally designed for because they have a particular goal that they're trying to accomplish within the day. And as a result, they'll pick the lowest common denominator to implement the solution, which is often in many cases, I won't say always, but in many cases, it will become the case that that code was written as a hack because they didn't really realize that there was a particular way that you needed to structure the code to really leverage the library to its fullest potential. So you'd want to learn those pieces, and in that respect, having documentation is very, very useful, but outside of documentation doesn't necessarily mean a tutorial. It could also mean tests. So there is a comment here. A challenge is that Lisp allows such rapid removal of cruft that there is much less rest time when reading code. Hitting the weeds feels like dropping out of hyperspace. This is actually a very good point, and I can actually attest to that. It's often the case because you're interactively programming something that while you're exploring, you're learning how stuff works. This is something that Common Lisp really embraced in a lot of, much more than the modern dynamic languages that give you a REPL today. It isn't just that you want to try out an API function. You are developing the application in real time. Image-based development is very, very different than developing an application using the edit, compile, run cycle, right? It's not. It doesn't necessarily benefit you if you don't learn how this cycle of interactive programming works. You're just literally switching it and updating it and changing it, and it's compiling in real time in that Lisp image that you're running, all right, in that Common Lisp image. That Common Lisp image is you could think of it like a running process, your virtual machine, your operating system that you're just changing in real time. Now, when you're ready to, and it was actually, let me just actually say this, it was actually at one point the case that that image was your final executable. Nowadays, most people start with a clean Lisp image and then compile everything, as a final before they set it up into production. But you could literally just save Lisp and die all the runnable objects. It will dump an image with all those objects in memory, and then you could just restart where you left off on another computer, and it would be just fine. That's one of the advantages, and it makes things a little bit even weirder when you're running stuff in Common Lisp. But I would argue that that kind of cycle allows you to experiment a lot more and allows you to come up with better ways of writing stuff, which makes the challenge really, can you write code that you can go back and read 6 months from now, understand introspectively how it's all written, and it's declarative enough that you understand what use cases actually it accomplishes, without having to like dive into the weeds through a debugger, which is often the case when you're using other languages. You put a breakpoint somewhere. How do I get to this function? Okay, let me go look at the stack trace. All right, based on this function and this stack trace, you get a mental model on the execution and how it all works. And that's, I would argue that that's even more getting into the weeds than in stuff that you would do in Common Lisp. Other questions? Comments? I really hope all of you are getting something out of some of these discussions and my talks. If there's a particular library or anything that you want us to explore, feel free to drop a line, even in the YouTube comments. I'm reading the YouTube comments in all of our videos on a daily basis just to see what people want me to talk about, and try to figure out particular things. Cells myself is kind of a personal vision and mission, just because I want to understand how cells worked, because especially when you're writing GUI programs, when I realized how useful reactive programming was written to writing GUIs and applications and even services, cells really kind of came into mind, because that was the first language, it was the first library that I saw before reactive, before the RX frameworks that actually embraced the style, which was really awesome. So George's point was that he's trying to bring up was there are beautiful libraries out there, and understanding them on their own terms, they are concise, which means one needs to understand the logic under the concision. I don't know how that's different than what I said, but okay. I agree with you. It sounds like we're saying the same thing, but I agree with you, George. The question that I was hoping to see. Recently, I was told I shouldn't use Lisp whenever possible. Are lists that bad? Okay, so short answer, yes. All right, lists are pretty bad. In Common Lisp or in any other language, a list is a console, all right, which consists of 2 pointers, right, the car and kidder, as you probably read if you read Practical Common Lisp, all right. That means that the data structure to get to a particular value is going to require two levels of indirection when you actually look at the compiled code, which you can certainly do so by doing a disassemble on any function call in Common Lisp. If you look at the disassembly especially, you will notice, and I can probably illustrate this pretty quickly with an example. Let me see if I can get this in. This is, where are you? This guy. And let me pull that up here. Okay. If we just define a simple function, add, let's say, at rest args, all right, and we do loop for I in args, summing I. Okay, just this simple function using already built-in libraries. All right. If we actually disassemble this guy, okay, add, you could see in a lot of things this thing called the generic plus. All right, and more importantly, you could see essentially a lot of data movement. This is what these move calls are. You're doing essentially a data access here to grab information about the counter variables and the contents of the actual addresses here, which could be potentially lethal if you're using a list, which is what we're using here, because if you're using the ampersand rest call, that actually converts your rest arguments into a list. So what that does is it could potentially be, like I say, a cache miss, and requiring you to actually get the value out of main memory, and that slows down computation as time passes. All right, but lists are particularly also worse in consoles in Common Lisp, particularly because they are heterogeneous. The type information is generic in Common Lisp, and you don't necessarily know what value a particular console has until you go and retrieve it, which means there are additional checks that needs to be added to make things, safer. Now, you could probably mitigate this by obviously declaring and using some of the type annotations to create type errors for you when you're passing in functions and getting errors that way. But in general, when you're developing, you're dealing with heterogeneous lists, right? And so the easiest thing to do is at that point is use, say, vector. You can use make array in order to create your vectors and deal with that whenever possible. And in that case, you'll be dealing with essentially an offset calculation. Actually, those functions, to manipulate them, you can also use them on, say, vector. If I do a def parameter test array, you may not be able to use car and coulter, but I think you could use first and rest if I remember correctly. First, I don't think, maybe. Hold on. This might not work. This will probably fail. Yeah, this fails because it's not a list. Yeah, you'd probably have to use, you'd have to use nth, if I remember correctly. This is also not a list? Ooh. Then it's ELT, that's even worse. Wait. Did I pass in the first argument wrong? Yeah, I did. Some of the sequence functions change. Yeah, I did. Dummy. That's the right thing. You'd want to use, so I'm not saying you need to completely avoid lists. All right, because you're right. There is a bunch of functions that just work on lists. But that said, especially for numerical calculations, and even dealing things with, say, loop, it's easier to run to use to stay as cons free as possible. All right, to minimize conses, because that also has an effect on garbage collection. All right. So I'm not saying that you should avoid them. You should minimize their usage. Don't become highly dependent upon them, because lists in Common Lisp are such a versatile data structure. It's not a list of single value. It's a heterogeneous tuple type, right? It You could code yourself into a performance bottleneck, and then that designing around that is going to be a lot worse. So you'd want to make sure that you know where in your code you cannot deal with lists, and you want to act accordingly. I hope that makes sense. Let me know, Daniel, if you want more clarification. So there was a question about if I use CL Project. Yes, I do use CL Project for my for my skeletal work. There are other ones out there. At one point, I was using Quick Project, which is Zach's project skeleton generator. CL Project was kind of more updated, and it worked really well with Roswell, which is what I switched over to using instead of using Quick Project for my stuff. But both I recommend, because it really depends on your use case. If you're using a different testing framework, Quick Project will create a bare bones skeleton for you, and you can create separate projects for each. Your testing as well, separate from your project itself, your source project. Whereas with CL Project, all that's generated upfront for you. So the easiest thing here, let's say CL Project. Okay, so quick illustration of CL Project. CL Project has this function called make project, which takes in the path. Okay, let's say we call this guy Roswell local projects. This will make it so that I can quick load it quickly. Let's call this sample CL project. All right, and here I'm going to go ahead and delete this, and this way I can show all the. And the name of this is just called sample CL project, right? You have author. You can also specify an author here. You have to specify depends on and add your dependencies. Okay. And then you see this last flag there without tests. That's basically giving you the option of generating a test template or not generating it. Right now, it assumes that you always want to generate tests. So let me go ahead and just use Alexandria here. All right. And when you generate this, if you look at the ASD file generated by this, dang it. That's what I wanted to do. Okay. If we go in here and load up the project, taking a minute here. My apologies. This ASE project creates 2 tests for you, right? Each of them are different different ASD section, okay? So you can do a quick load on either sample project or sample project.tests, and it'll do the same thing. So if you do a quick load here, sample CL project / tests, it'll go ahead and load the test suite, which includes Rove. Rove is actually the predecessor to Prove, and I haven't actually switched this over to using Prove just yet. But once we do that, you can actually go ahead and load okay, so it has to be, so the question is it has to be in a specific directory, right? The Lisp files, yes, have to be in a specific directory. If you look at the project structure here, and I'll probably, the easiest way to probably do this is fire up eShell and just show you the project structure. Let's do that eShell. If we actually just list this, you have these 2 directories. You have a source and test directory. All tests obviously have to go into tests. All source files have to go into source. I don't think I have to explain those 2. If we go back to the ASD file, obviously if you wanted to add multiple stuff here, you could certainly do so. I don't know if how familiar you guys oh, I stand corrected. There was a comment saying that Prove was deprecated in favor of Rove, not the other way around. Okay, my apologies. Rove and Prove have the same API in terms of their tests that you will never notice the difference, which is why I sometimes mix up the 2. But thank you for the clarification there. So I don't know if how familiar you guys are with how these project skeletons are working through CL Project, but in CL Project, Fukamachi is of the opinion that everything should be, from package declaration to definition, should be in the same file. So in older CL projects, common Lisp projects, you may have encountered a Lisp file known as def package, all right, or package.lisp, okay, depending upon either def package.lisp or package.lisp. Okay, package.lisp normally in the old pre-Quick Lisp, and I think around the time that ASD was invented, the standards of practice was all your packages should be in a single package Lisp file, and then each of your individual files will reference that package. So if you want to look at your quote-unquote API definition, you can just simply go to package.lisp and look at the list of exported symbols, and then everything is good. But when Fukamachi started creating CL Project and his project skeletons for his work, he came up with a different package approach. He's like, well, if I want to know my exported symbols for an API, I would probably want to do what Python does, which is make a file determine what exported symbols are in the file. Right. So he treats the file as the module definition. So in order for you to do that, you have to have your def package at the top with all your list of your exported symbols, and then you do your im package, and then write your code accordingly. So that's what we're going to be doing here, just very, very quickly, just to illustrate how to run tests. I need to first define a function. Okay, I'm going to go ahead and open up source main.lisp here, And you'll see automatically already that there's this def package here. Here, I'm just going to say export, and I'm going to export an add function. And in here, I'm going to go ahead and define this add function. It will take two values, simple function, adds. And right now, I'm not going to do anything, all right, which means to prevent any sort of I'm just going to ignore these two things, okay? So now let's write a test for this, okay? Because now that we have an exported function, we could certainly write a test. And let me, yeah, I'll go ahead and even do this. Let me load. So in order for this to work, you need to load also, I don't believe it loaded sample. Oh, it did. Okay, so I can actually load this now again. Because obviously, since I just exported a symbol in there, we have to go and reload. So let me just go ahead and reload this guy. So it realized that the package got updated and it'll reload it. Okay, so now I have a exported symbol in here. I can go and open up my test directory, main.lisp, and you could see already that there's a def test in here as an example. Okay, you could certainly do so using this this simple thing. One thing to note for folks who are looking at this. If you're using CO project or if you're using Rove, they recommend you just using in the package definition the symbols that you're going to be using. So in this case, CO project and then Rove. So this way you don't even have to actually add anything here. But the structure of the test is going to be the same here. It's going to define a test. You're defining a test case or testing, and then you go ahead and write OK is essentially like is. In your JavaScript testing frameworks where you provide a condition. Okay, so here we can just go ahead and say test add. We're going to do testing, and we write a quick description here. Okay, if you look at it, description first and body. Add should return 2 when passed 1 and 1. All right. Now I'm going to do OK equals to add 1 and 1. And you're going to see this and this here. Now the one thing to note here is it already provides a test command here. All right, asdiff test system sample project. Okay. That's because Rove actually ties into the ASDIF system very so intricately that you could just use ASDIF's built-in API to call the test system. And what it does is ASDIF test system looks up the test package, figures out what tests are available, and then runs them, right? Regardless of the package that you're running on. This gives you the ability to actually switch between testing frameworks if you really need to. This way, if you want to switch from, say, 5 a.m., from Rove to, say, 5 a.m., you could certainly do so. Again, I had some trouble when I did this last time, but it's been a few years since I've touched this, so it might be the case that things are getting better here. So now we don't have to switch between the package to actually run these tests. You can just simply do this, and it will run all the tests accordingly. As you can see here, it'll run a nice simple. It'll give you this nice little command line output here in your REPL, saying that sorry I failed when I tried to add 1 and 1 here, and everything should be fine if you go ahead and update this guy. So if we do this, say AB, okay, Shift G here, go up, run it, and you'll see everything gets compiled and you can run all your tests. Okay. I think Rove also has run tests as well, and you could actually certainly use that too as well. obviously, in order for us to do this, we're going to have to switch over at this point then to this package, which you could switch over pretty quickly by running in slide. There's a way to actually change package to actually load this up. And then once you do that, you could just do rove run, and then you could run the test. I think you have to specify it has a. Hold on, let me just go and double check here. Rove run. It runs a test package. Oh, I'm sorry. So I have to run, if I'm in package CL user, I could do rove run sample CL project /test /main. Oh, sorry. Do I have to do it that way? Interesting. It says runs a test package. I know if I run it has a sample project test /main. See something here. It requires me to go to the top level. It doesn't actually. So rove run actually requires me to do /test, not /test /main, because it'll go and run them each individually. But you can also do rove run tests in the test name. So in this case, we have test target 1. I think you have to pass it as a quoted thing. I don't think it's a string. And it'll run those explicit tests. So here, if we do test add, and it'll run those individually. All right. Okay, so there's a comment, main.lisp. I think you're asking about the main.lisp here and the subsequent main.lisp in the test file. So CL project skeleton makes a assumption that you're going to ultimately create an executable the first time you generate it. So as a result, every Lisp executable, if you're doing it, you're going to define a main entry point because that's what's passed into Lisp save Lisp and die function to actually go and dump and create an executable for you. Most people often put that main entry point into main.lisp. All right. What Fukamachi did is you know, main.lisp is the name of the main function. Let's name our files in the test directory to match the name the file name in the source directory. So this way you don't actually have to look at the name, and you don't have to create a mnemonic. Most people use a mnemonic. They're like, oh, if we're writing a test, it's going to be test / file name _ test.lisp or something like that. In Rove and CL project, he just kind of assumes that if you have a source / filename.lisp, you'll have a test / filename.lisp. So that way you can just look at the one-to-one directory structure to figure out if there's a file in source named main, there's going to be a file in test named main, which will have all the tests associated with it. Does that make sense? There was a comment about what about projects where tests are in the same directory. Good question. If you want to move this over to move this project that has your tests in the same directory to using a CL project structure ASD file, all you have to do actually is update the ASD file and create a new system definition, and then you could specify all the components that you want to actually build in the component section of that definition. You can have them in the same directory. Do I recommend that? No. In general, I do know that unless you're using a tool like Go, all right, Common Lisp doesn't have this, where it can distinguish and automatically do, like if you do a Go build or a Go test, it could filter out all that information. Since you have to write it yourself, I personally don't like cluttering my source with tests. I like my source directory to have source, then my test directory to have tests. So this way, I can actually know what I'm looking at when I'm going through stuff. I understand that it's useful for some cases to have both of them in the same directory, just so that you can make, like, say, a pre-commit hook that says if there's not a test for this file, don't commit it. But I would make the argument that you could do the same commit hook if you have a directory. But that's just me, and personal preference. Your mileage may vary. Other questions? I can't believe we've actually we're going a little bit over than what I expected, but you know, this is a great conversation, so go for it. Okay, if there aren't any other questions, then I'm going to end the stream. I appreciate all of you joining, and I really appreciate the questions and conversations we've been having. I learned quite a bit today, and I hope you guys did the same. I hope to see you guys next week. Thanks.